Welcome back, crew. We're going to finish up your 13.1 notes today, and we're going to call these 13.1b part 2, where we are defining a geometric sequence. So here we go. If we can take consecutive terms and divide them and always get the same number, then we're looking at a geometric sequence. So if I take the second term, divide the first. If I take the third term and divide by the second, if I take the fourth term and divide by the third, or if I take any term, a sub n, and divide it by its previous term, a sub n minus 1, and always get the same number, let's call that number r, then that number r is called our common difference, and our sequence is geometric. For a geometric sequence, we have two types of definitions. We looked at these types for arithmetic. One is the recursive definition, which says that a sub n, which would be any term, is equal to a sub n minus 1, which would be any other term, times r, that common difference. Our explicit definition is going to allow us to find the value of any term without needing to know its previous term, and that is a sub n is equal to a sub 1 times our common difference raised to the n minus 1. So let's use those definitions, and we're going to start with this sequence. So I'm looking at this sequence that goes 32, negative 16, 8, and so on. And when we try to determine what type of sequence we're looking at, the first thing we typically look for is to see if it's arithmetic. So what I'm going to do here is I'm going to start with my test for arithmetic. So I'm going to do an arithmetic test where I'm going to take the second term, which in this case is negative 16, and divide it by the first term, which is, nope, sorry, not going to do that. I'm ahead of myself here. We're going to take the second term, which is negative 16, and subtract the first term, which is 32, which gives us negative 48. Now we're going to take the next term, the third term, which is 8, and subtract its previous term, which is the second term, negative 16. That's 8 plus 16, which is 24. Since these two terms are not equal, right, therefore this sequence is not arithmetic. Okay. Now, let's look at whether it could be geometric. So the way we do a geometric test is we take the second term, negative 16, and we divide it by the previous term. Here that's 32, and we get negative 1/2. So the question is, do we get that same number when we divide the next set of terms? So if I take the third term, 8, and divide it by negative 16, I reduce that. I also get negative 1/2. And in this case, I also get that when I divide the next term, negative 4 by 8, and 2 by negative 4, and negative 1 by 2. Since all of those equal the same number, right, they equal negative 1/2, then that is our common ratio. R is negative 1/2. If I want to find the 8th term, I would need to know the 7th term. So what I have here is I have the first term, the second term, the third, the fourth, the fifth, the sixth. So since the 6th term is negative 1, the 7th term is going to be negative 1 times my common ratio, which is negative 1/2, which is 1/2. And then my 8th term is going to equal the 7th term, which was 1/2, times my common ratio, which is negative 1/2, which gives me negative 1/4. So my 8th term, a sub 8, is equal to negative 1/4. My recursive rule, right, if we go back, my recursive rule followed this format. A sub n is a sub n minus 1 times r. So here my recursive rule will be that a sub n is equal to a sub n minus 1 times our common ratio, which is negative 1/2, and our explicit rule will be a sub n equals a sub 1, which here is 32, times our common ratio, negative 1/2 to the n minus 1. All right, so that's one example. You do the next one. So pause the video, come back, and we'll check this next one. Okay, so hopefully you found that your common ratio here was 10 to the negative 1 divided by 10 to the negative 3rd, which is 10 to the 2nd, or 100, and we would use whichever form we thought was the most useful. To find our 8th term, right, we would keep multiplying by 100, and you should have found that that 8th term was 10 to the 11th, which we'll leave in that form. That's a pretty big number. Our recursive rule would be that a sub n is a sub n minus 1 times our common ratio, which is 100. And our explicit rule would be a sub n is a sub 1, 10 to the negative 3rd, times r, and I'm going to write it as 10 squared here because I can multiply powers of 10 pretty easily, and we'll raise that to the n minus 1. Okay, so now let's look at how we can use these to find a sequence when we know a couple of the terms and what type it is. So we'll start here with this alternate definition. We're not going to spend a lot of time here. We'll come back to it if we need it later on, but it's just that a sub p, which again is any term, equals a sub q, which again is any other term, times r to the p minus q. So if I knew a sub 7 and I knew a sub 4, I could write that a sub 7 is equal to a sub 4 times r to the 7 minus 4. Okay, but we're not going to use that definition here because there's just more continuity in what we've done before to solve this as a system like we've done in other settings. So let's do this. I know that a sub 2 is equal to, I know a sub 2 is equal to 2, so the second term of my sequence is 2. I know that a sub 6 is equal to 162. My job is to find the first term, so I need to find what a sub 1 equals, and a recursive and explicit definition for the sequence, so I need to find two different definitions for a sub n. Right? I know that for me to find the recursive definition and the arithmetic, I'm going to need to know what r equals. So I'm going to need to know what r equals as well. So we're going to start with those two terms, and we're going to plug them into our explicit form just like we did with arithmetic. So let's just review that our explicit form for geometric is a sub n is equal to a sub 1 times r to the n minus 1. So if we're going to work with the 6th term, the further along term first, and we know that if a sub 6 equals 162, then 162, that's my term value, is equal to my unknown a sub 1 times my unknown r raised to the n, and in this case n is 6, so raised to the 6 minus 1. If my second term is 2, then I have a sub 2 is equal to 2, and the term value, which is 2, will equal a sub 1 times r, both of which we don't know, raised to the 2 minus 1. So simplifying those, this becomes 162 equals a sub 1 times r to the 5th, and the second one becomes 2 equals a sub 1 times r to the 1st. Okay, what are we going to do? Well, we're going to come in here and we're going to divide both of those. So I'm going to divide both sides, and when I do that, 162 divided by 2 is 81. My a sub 1's divide out, and I'm left with r to the 5th divided by r to the 1st, which is r to the 4th. So I want to solve for r. Let's raise both sides to the 1/4 power. And what we get from that is that r is equal to 81 to the 1/4, or the 4th root of 81, which is 3. Okay, so we now know that r is 3. I want to find what a sub 1 equals, so I'm going to take this equation just because its numbers are smaller. It would work with the purple equation as well, and I'm going to write 2 equals a sub 1 times r, which is 3. Solving for a sub 1, we get a sub 1 is equal to 2/3. So we now know a sub 1, it's 2/3, and a sub n will equal a sub n minus 1 times our common ratio, which is 3. That's our recursive definition. And for our explicit definition, a sub n will equal a sub 1, which we now know is 2/3, times r, which is 3, raised to the n minus 1. Okay, pause the video, you do the next one, and then come back and we'll check. Okay, so what you should have had here is that 24 equals a sub 1 times r to the 5 minus 1, so to the 4, and 3 equals a sub 1 times r to the 2 minus 1, r to the 1. If we divide those, you end up with 8 equals r cubed, or r equals 2. If r is 2, right, then using this equation here, you end up with a sub 1 is equal to 3/2. So our recursive definition, a sub n equals a sub n minus 1 times our r, which is 2, and our explicit definition, a sub n equals a sub 1, which is 3/2, times r to the n minus 1. Okay, that does it. We're not going to do the back side. Just in light of everything we're dealing with, we're just going to do what we really need to do. You can always look at that and play with your calculator. It's kind of interesting to be able to do that, but you should be ready to finish up your homework assignment here.